Okay, we continue with example 3. Find limit x to 0, x ln x. Okay, this question actually in previous semester papers. In semester December 2018. Question 2A and carries 5 marks. Okay. And this example is under type 3 because when we substitute 0 into variable x, so we have 0 times ln 0 is infinity. Okay, so we have 0 times plus minus infinity, which is under type 3. Okay, and it is also indeterminate form. Okay, when we evaluate limit under indeterminate form, we need to use L'Hopital rule. Okay. Now, the given function is in terms of multiplication function. When we use L'Hopital rule, we need to write into the form of either 0 over 0, which is fraction, and infinity over infinity, which is also fraction. So, what we need to do is, first step, we need to turn the multiplication function into fraction before we apply L'Hopital rule. Okay. Okay, from the given function, okay, between x and ln x, okay, x is easier to change into denominator because we want to write into fraction. So when we move x to denominator, so we have x the power of -1 under properties of indices. Okay, so now we have ln x over x the power of -1. Okay, and then from here, okay, we try to use direct substitution. And when we use direct substitution, okay, we substitute 0 into variable x here. So we have ln 0, which is infinity. Okay, and then 0 the power of -1 means 1 over 0, which is also infinity. So now we have into the form of infinity over infinity. Okay, in type 2, indeterminate form. So from here, we can use L'Hopital rule. Okay. And when we use L'Hopital rule, we need to differentiate numerator and differentiate denominator. Differentiate one by one. So we still have limit here. We differentiate ln x, we have 1 over x. And then we differentiate x the power of -1, we can use power rule. Okay, we move -1 to the front, so we have -x, and then we minus -1 minus 1. Okay, so we have -2 here. Okay, and after that, we can move x the power of -2 up to numerator using properties of indices. When we move x the power of -2, okay, when we move up, so we have x the power of +2 or x squared, and then we positive divide by negative here, so we still have negative sign here. So we have 1 over x, -1 over x, and then we move x the power of -2 to numerator using the properties of indices. So we have x squared or x the power of +2 here. And from here, we can simplify x squared and x. Okay. And after we simplify, we have limit x to 0, -x. And from here, we can use direct substitution because no more in the form of 0 over 0 or infinity over infinity. Okay. So when we substitute 0 into variable x here, we have -0. Okay. So we just put 0 here. Yeah, because 0 is not negative and not positive numbers. Okay. So we just put 0 here. Okay. This is the final answer. Okay. You can check the answer using Symbol Lab. Okay. But make sure the syntax is correct. Okay, we have limit x to 0, and then x, ln, okay, and then x in ln, you must put bracket. Okay, And then we just enter or we press go. And then the complete solution will appear. And the final answer is 0. Okay? Got it? Okay, now we continue with example 4. Find limit x to 0, 1 over e the power of x minus 1 minus 1 over x. Okay, you can refer this example in page 19 in chapter 2 in your handout. Okay, this example is under type 4 infinity minus infinity. Because when we substitute 0 into variable x, so we have e the power of 0, which is 1. 1 minus 1 is 0, so we have 1 over 0, which is infinity. Minus 1 over 0, also infinity. So, this example is in the form of infinity minus infinity, which is also indeterminate form. So, to evaluate limit for indeterminate form, we need to use L'Hopital rule. Okay. From the given question, we have two fractions here. Okay. Every time when we want to use L'Hopital rule, we need to write into the form of type 1, 0 over 0, or type 2, infinity over infinity, okay, which is in single fraction. Okay. So, from double fraction here, okay, we need to write into single fraction. Okay. What we need to do is, we need to standardize the denominator and write it down into a single fraction first, before we applying L'Hopital rule. Okay. Okay, after we standardize denominator, so we have denominator x times e the power of x minus 1. And numerator, okay, we have x times 1, which is x, and then 1 times e the power of x minus 1. And in between is minus. So, if in between is minus, we must put bracket to avoid error. Okay, because when we expand, it will change the original sign. Okay. After that, we expand and simplify. Okay, so we have limit x to 0, x minus, we expand here, so we have x minus e the power of x, minus minus, so we have plus 1. And then we expand the denominator, so we have x e the power of x minus x. Okay. From here, okay, if we use direct substitution, we substitute 0 here. So 0 minus e the power of 0 is 1. So 0 minus 1 plus 1. Okay, so it becomes 0. And in denominator, if we substitute 0 into variable x, so we have 0 minus 0, which is 0. So this is under type 1. So now, from double fraction here, we reduce to single fraction. And then, we get into the form of 0 over 0. Okay, when we get into the form of 0 over 0, so from here, we can apply L'Hopital rule. Okay, and every time when we apply L'Hopital rule, we need to differentiate numerator and differentiate denominator. Okay, so we still have limit here. So we have limit x to 0. We differentiate x equals to 1. We differentiate e the power of x equals to e the power of x. And in between still minus. And then we differentiate constant 1 equals to 0. No need to write. Okay. And then from denominator, we differentiate x e the power of x. Okay, this is multiplication operation. Okay, so we need to use product rule. Okay, I show you how to use product rule here. Okay, to differentiate x e the power of x, okay, using product rule, our u is x. And then our v is e the power of x. And then we need to find u prime and v prime. Okay, our u prime is when we differentiate x, it becomes 1. And then when we differentiate ex, we get back e the power of x. Okay, this is our v prime. Okay, and then from here, okay, when we use product rule, we can use formula vu prime times uv prime. Okay. So it become, okay, when we multiply VU prime, so we have e the power of x times 1, which is e the power of x, plus UV prime, so x times e the power of x. So when we differentiate e the power of ex, x the power of ex, using product rule, the answer is e the power of x plus x e the power of x, using product rule formula VU prime plus UV prime. Okay, and then we differentiate minus x, so we have minus 1 here. Okay. Okay, from here, again, we can try to use direct substitution. Okay, and when we use direct substitution, we substitute 0 into variable x here, here, and here. So we have 1 minus e the power of 0 is 1. So we have 1 minus 1, which is 0. And then, in denominator, we have e the power of 0 is 1. 1 minus 1 is 0. And then x here is 0. Means that denominator also equals to 0. So we still get into the form of type 1 0 over 0. And this is indeterminate form. Okay, so we still need to use L'Hopital rule to evaluate the limit. Okay, we need to repeat, okay, L'Hopital rule. As long as the previous application of L'Hopital rules produce an indeterminate form, it is okay to repeat it as many times as necessary to reduce the limits to a form that can be evaluated. Okay. So from here, when we apply L'Hopital rule, we differentiate numerator and we differentiate denominator. Okay. So we differentiate 1, it becomes 0. We differentiate e the power of x, it becomes e the power of x. And then from denominator, we differentiate e the power of x, it becomes e the power of x. We differentiate x e the power of x. We use same technique when we differentiate e the power of x just now. Okay, we use product rule. Okay, our u is x and our v is e the power of x. And then we differentiate x, we have 1. Okay, and we differentiate e the power of x, we get back e the power of x. And after that, we substitute into product rule formula, which is VU prime plus UV prime. So we get this. Okay, and then we differentiate negative 1. Okay, we get 0. No need to write. Okay. Okay, after that, we try to use direct substitution. Okay, when we use direct substitution, okay, means no more limit expression here. So we have e the power of 0, okay, which is 1, okay. So means that the fraction no more in terms of 0 over 0 or infinity over infinity. So means that start from this point or this step, okay, we need to use direct substitution. Okay, we substitute 0 into variable x here, so we have negative e the power of 0, okay, which is negative 1, and then we substitute here e the power of 0 is 1 plus e the power of 0 is 1, and then the final answer is negative 1 over 2. Okay, no more indeterminate form. Okay, you can check your answer using Symbol Lab. Okay. Okay. Using Symbol Lab, you need to put the syntax exactly like the given question. Like this. Okay. And after that, we press go or enter, and then the solution will appear. Okay. And the final answer is negative half. Okay. Got it? Coming up next, example for type 5, which is 1 the power of infinity, 0 the power of infinity, and infinity the power of 0 using L'Hopital rule. Okay, thank you for watching. Stay tuned. Bye. Assalamualaikum.